Number 6, find the exact value of the expression, do not use a calculator. And here we're given cosine inverse of cosine of 11 pi over 10. So what we're going to have to do is check to see if this angle that's on the inside of our cosine is in the range of our cosine inverse, which is not too difficult. So we'll have to remember the range for cosine inverse. Well, for cosine inverse, the range is the first and the second quadrant. Now, if we were to draw that out, we could just draw something like this to remind us. Well, we need to check 11 pi over 10. So is 0 less than or equal to 11 pi over 10 less than or equal to pi? Because that's where the first quadrant starts and the second quadrant ends. It is not. So what we're going to have to do is find the angle that is, but gives us the same value for cosine. So 11 pi over 10 is just a little bit bigger than pi. So it probably is somewhere right about here. Doesn't have to be exact, we're just trying to get a good estimate of what's going on. Well, I know if I were to flip this angle, or this line, over my x-axis, then right here, I would have the same exact value for cosine. It's because cosine is negative in quadrants 2 and 3, and when I flip, I get the same value. So if I can find out how far I have to go from pi to get to the angle I was given, I can go backwards that same bit to get the angle that I need. Well, the difference between pi and 11 pi over 10 is pi over 10. So I know if I start at pi and move clockwise, pi over 10, so take away pi over 10 from pi, I will get to an angle that'll be in the range of cosine inverse and will give me the same x value as cosine. So I'm going to take pi and subtract off that pi over 10. Which is 9 pi over 10. So what's happening here with this cosine inverse of cosine? We're plugging in this angle into our cosine function, and it spits out an x value over here. Well, my inverse function is looking at that x value and going, okay, I need to find that exact same x value, but in either quadrant 1 or 2, and see what angle gets me there. Well, the angle that gets me there in quadrant 2 is going to be 9 pi over 10. So my answer is 9 pi over 10.